All right, so the first thing we need to do is open up NVIDIA Insight Compute, which is the GUI to look at the logs that we captured earlier. You'll go to Open File and navigate to the last log that you captured. In this case, we already know that the results are suboptimal, but sort kernels by duration to get your longest running kernel. Double click on the statistics and you'll pull up this page. So the first thing we see for this kernel, poor compute, poor memory utilization. Both are bad, which is a red flag, but this looks like a memory bound kernel because memory has more utilization than compute. But because it's a matmul kernel, we have some intuition to know that it should be compute bound. So we look up at our launch parameters and see that we're launching a very suboptimal grid dimension and then taking super tiny chunks out of it for our individual units. This execution leads to poor memory throughput because we're spending most of our time in launch, and then it leads to poor compute because we're spending most of our time in launch and only giving the thread a very small amount of memory to process. Now, if I saw this, I would immediately run the tuning step and see what we could get out as an improved metric, which is what we did here. And the very first thing you'll see is we went from a duration of 418 milliseconds down to 10.9, and we also see that matmul is still our longest running kernel. Looking at this, we'll see that our compute utilization is now 92 and memory is 55. This is in alignment with what we would expect out of a matmul operation. We can also see that our launch parameters now are much more reasonable. We can see that we are giving enough to the thread to occupy it, and we can see that we're not spending so much time in compute suboptimally that we're not using our memory throughput, but balancing these two to improve throughput further will take getting into more fine metrics that we will discuss in later examples, but we now know that this kernel, although not perfectly optimal, is much closer to optimal.